Good day. So today we're gonna be speaking about a certain topic that is very interesting. Right now we'll be talking about electricity and magnetism. Right. Let me try to move this. Where is it? Magnetism, right? So now with electricity, we studied these topics in grade 10 and 11, right? So now when we talk about electricity, we're going to be focusing on three variables, which are current, potential difference, and resistance. Now this is in terms of electricity. All of this, they fall within electric circuits. Let me remove this I here. Okay, it's fine. Electric circuits, right? So now we know that in electricity we have current, and current is the flow of charge, right? Flow of charge, right? Now we also know that we have what we call the potential difference. This is the flow of current, right? Then here we have resistance. This is the impedance, right, of the flow of currents. The impedance of current flow right? Now when we talk of impedance, this is where we talk about apparatus that reduce, right? Then instead of saying impedance, we can say the reduction of current flow, right? So now with electricity, all these three variables, they make up what we call Ohm's law, right? Now Ohm's law can be defined in terms of current or in terms of potential difference, but I prefer starting with current. And the definition of Ohm's law is that current in a metallic substance, right? Remember, we have V equals to IR, right? Then I is equal to V over R, right? So current in a metallic substance and across 2 points, okay, is directly proportional to the potential difference and is inversely proportional to the resistance, provided that the temperature remains the same. Current is directly proportional to the potential difference, and current is inversely proportional to the resistance, provided that the temperature is constant. That means that the moment temperature changes, then this entire system will also change. So, but now this is what we call Ohm's law. It follows the order Y equals to mx plus c, but in this case it's Y equals to mx, right, where c is 0. Now V becomes your Y value, then I becomes your gradient, then R becomes your gradient, then your I becomes your X, right, your input value. So this one is constant, this one can change, and this one is determined using this one. current is in a metallic substance is directly proportional to the potential difference. This means that if current increases, then the potential difference will increase. Now, if current decreases, now the potential difference will also decrease. Similarly, if we increase resistance, current will decrease, meaning potential difference will do what? Will decrease. So now if we decrease resistance, current increases. So if current increases, potential difference increases. That is basically what we mean. That's why we're saying it follows the order y equals to mx, right? So now m becomes your r, right? Then x becomes your I, then the v equals to that, right? So in some books they put it in this form because of this rule here. So now, but that's a debate for another time. So in circuits we have connections, right? These connections are either parallel or they are in series. So now, what are series connectors? What are parallel connectors, right? We can try to draw an example of a parallel connection and a series connection, right? This is the simplest form of a parallel connection, right? Like this, then like that, then like that, right? And like that. Something like this, then like this, and so on and so forth until we reach this point, right? So now this is going to be your ammeter reading, right? This is going to be your voltmeter reading, and this is going to be a resistor 1, then this is going to be a resistor 2, right? This is going to be a cell, right? Then we may even add a bulb here and a switch, right? So now this is a parallel connection. A series connection can take this form. Let's say this is resistor 1, then this is a voltmeter, and this is resistor 2, like that, then like this is going to be your ammeter, right? Now we have resistor 1, we have resistor 2, right? And this is your battery. Now what are the properties of these two circuits, right? The properties of these two circuits, let's start with the properties of parallel connection. In parallel connection, we say the potential difference remains the same, meaning that your total voltage is equal to your V1, which is equal to your V2, which is equal to your V3, right? Then current 1 equals to, current total equals to I1 plus I2 plus I3. Now they are what we call current dividers. Series are what we call current dividers. Now that is what we mean when we talk about electric circuits that are in parallel form, right? Now that's what I want you to get from this, right? Current divides, potential difference remains the same. Again, 1 over Rp, right? The effective resistance of this is going to be 1 over R1 plus 1 over R2, right? Plus 1 over Rn, right? N represents any number. Even here we can say Vn, even here we can say In, right? Which represents any number. So now we can say, or your Rp is equals to your R1 plus R2 over R1 plus R2. How did this formula come to play? It came to play in this sense. 1 over Rp is equals to 1 over R1 plus 1 over R2, right? Now, what is the lowest common denominator of this? The lowest common denominator of this is going to be R1, R2, right? Now, for this one, R1, R2 divided by R1 is R2. R2 multiplied by 1 is what? Your R1, right? I mean your R2, sorry. Plus. So you have your R2 here. R1, R2 divided by R2 is R1. Multiplied by 1 is R1, right? Now working this, we finally say this ones here, they automatically, because we've solved this, we no longer consider them, right? So now what we left with here, yes, at R1 plus R2 multiplied by, right? Not addition. So now your RP here is going to be what? R1 plus your R2 over R1 by your R2. Now that's basically what we can say about this, right? So let's get to the other part, which is the parallel form, right? So with the parallel form, I mean with the series form, the series properties, right? The properties of circuits in series, number one, we said the potential difference divides. V tot equals to V1 plus V2 plus V3, right? Then number two, we said current remains the same, meaning the total current is equals to initial current, the second current, the third current, and so on. Now number three, we said your R tot is going to be equal to your R1 plus R2 plus your Rn, right? Even here we have your In, here we have your Vn. So now basically these are called potential dividers, meaning that the potential difference divides in series form, right? The potential difference in this resistor is not the same as the potential difference in this, right? Now this plus this will give you this potential difference here. So now we're going to add a twist to the story. All of these circuits, they have one thing that we know or we may not know, which is called the electromotive force. Now you may wonder, what is this electromotive force? Electro means electricity, then motive means motion, right? Then we have force. Now like any traveling medium, electricity or current that is used to create electricity will have motion, and that motion is due to a force. Remember Newton's second law, F net equal to ma, right? So now with this one, it's going to be more or less of a similar story, but in a different form, right? So now electricity, before it goes out of the cell, this cell, there has to be what we call internal resistance, right? So now we can simply say that the electromotive force is equal to, now remember a circuit has two forms, right? We said V equals to IR, right? So now if we are to look at this circuit here, we would say this is the the external resistance. This is the resistance outside. Now there is another resistance here in the cell within the battery, now that we did not mention. So now the V equals to IR, we can say the electromotive force is equals to V internal plus the let's say V external plus the V internal, right? External, internal. So now what do we mean by this? IR plus IR, right? For this small r is equal to your internal resistance. Now this one is external resistance. Now we can work this out to say I into R plus R, like this. This current remains the same. This is the total current, right? Now this is going to be your internal resistance and this is going to be your external resistance. That is basically what you're gonna be dealing with most of the time in grade 12, right? You have to be ready to speak or to calculate the electromotive force of an object. Now that is basically that, right? So now I made a mistake here. You'll forgive me. I made a mistake here. Remember, this is going to be 1 over R1, right? So now we want to work this. If we want to work this, we have to cross multiply, right? This one will multiply this and this will multiply that R. So now the formula is not this one. This is where I made a mistake. The formula is going to be what? Let's calculate this. RP into what? Your R1 R2, right? No, sorry. RP is equals to R1 plus R2, right? Which is equal to here we're going to have your R1, your R2, right? Divide by R1 plus R2. RP is going to be R1 R2 over R1 plus R2, right? That was the only mistake I made here, right? So now that's basically what we'll need to talk about. So that is basically what we can talk about, right? So now let me check something here. Yeah, so now that we know the properties of the external and the internal connections and whatnot, I'm not gonna go much into detail on once the use of the circuits and whatnot. So yeah, so what I'm going to do, I'm just gonna get straight to calculations, right? And let's try a simple exercise together so that we can have a way forward on this, right? So okay, here we have a circuit, right? Here we have a circuit. They're saying this circuit is in this form, right? Sorry. No. But then here we have another one here, right? Then we go like that, then we go like that, then we go like that. Yes, then something like this, right? Let me it's gonna remove the whole thing, so you'll just bear with me. I'm not good at drawing, so let's see. Let's say this is another one here, and let's say this is another one here, right? Then let's say you have your voltmeter here, then here you have your potential difference. So whatnot and whatnot. Yeah, something like this. It's not accurate, but yeah. This is your I, right? Then they said this battery carries 24 volts. 24 volts, right? Now this one here, they said is a 1 ohm resistor. It's a 1 ohm resistor. Alright, so now this is a 9 ohm resistor. This is R1. Okay, now this is your internal resistance here, right? So now this is your external resistance, you call it the R3, right? So this is R1 here, this is your R2, right? R1 is equals to 6 ohm, then this one here is equals to 3 ohm. So now in this circuit, the battery has an electromotive force of this. Now E equals to 24, right? Now the electromotive force is the total potential difference within a battery, right? So, and an internal resistance of that much. So now they're saying to you determine the current in the circuit. Now to determine the current in the circuit, we can use we can try to find the effective resistance of the external circuit, right? Now remember, if we are to draw this in such a way that we can understand this is how we can represent it, right? Now you're going to have your internal resistance here, then here you're going to have your other resistance here, then and then it's something like this, then you're going to have what, something like this again. So now what's going to happen is that the two are going to do like this. Then your R1 is here, your R2 is this one. So now we've drawn it like that. So now the V is going to be here like this. This is the simplest form of redrawing this one here. So now this is going to be your R1, your R2, your internal resistance, your R3. This is your voltmeter, right? Now this is your cell, right? So now the electromotive force is that the internal resistance is 1 ohm, right? So we have to find the effective resistance within the circuit. Remember, we have two parallel circuits here. So your Rp is equals to your R1 R2 over R1 plus R2. So now what do we do on to about that? R1 is 6 ohm times 3 over 6 plus 3, right? So now we have 6, 12, 18. So it's 18 over 9. 18 over 9 is 3. So the effective resistance in parallel is 3. Now the external resistance all in all is going to be what? 3 plus, remember, this is going to be one thing, it's going to be 3, right? Then it's going to be 3 plus 9. Now 3 plus 9 is 12, right? Sorry, okay, this cannot be 3 here. I made a miscalculation here. This has to be 2, sorry. The mathematics is running with me now. Okay, good. So this is going to be 2 plus 9, right? Then 2 plus 9 is 11. Yeah, something like that, right? Now we have the external, we have the internal. The internal is what? Is 1. So we can just add this into one thing and call it the effective resistance, or we can just use it in the equation. Now in the equation, remember that it's going to be what? E equals to IR, right? Now this is the effective resistance, right? Now E will be equal to I into your external and your internal. Now I will be equal to your E over your R plus your R, something like this. So now this is going to be 24 divided by 11 plus 1. Then you have 24 divided by 12. This has to give you 2 ampere, right? Now let's go to B. They say calculate the reading of the voltmeter. To calculate the reading of the voltmeter, we can use the parallel equation, right? So we can simply say that V parallel is equals to I parallel times your what? Your RP, right? So now current is 2, then your parallel connection is 2. Then having that 2 by 2 is what? Is 4. Now the effective, the current in the voltmeter reading here is going to be 4 volts. The voltmeter reading here is going to be 4 volts, right? Or you can alternatively choose to use Vp equals to E minus your VR, the small letter r, your internal current, minus your VR3, right, which is going to be your series connection. Here you're going to say 24, right, minus what? 2 by 1 minus what? 2 by 9. 2 by 9, right? So what you're going to get there? Let's see. 24 minus 2 minus 18, right? Now this is 24 minus 20, then your answer is 4 volts. So we still get the same thing. Remember, E equals to V, in this term is going to be what? Your Vp, right, plus your VR plus your V series, right? Then it's IR. So now you can work with this, right? So if we want the potential difference in parallel, so Vp is going to be equal to E, take this to the other side, minus VR, take this to the other side, Vs. This means VR3, it's in series, potential difference in series. So now this is the route, the longest route, and this is the shortest route, right? This one here, you just choose which one you can use. So basically that's just that. So they ask the question, what will happen to the voltmeter reading if R2 is removed in the circuit? Explain without using the calculator. Okay, let's go to the circuit. They removed R2. This one is no longer there, which means it's in series form. So what happens to it in that regard? What will happen to it? What is going to happen is that the resistor R2 is in parallel with R1. Now if we remove R2, the resistance of this part of the circuit will increase, right? So now the 6 ohm compared to 2 ohm previously, this increase in resistance results in an increase in voltage across this path, right? Remember, V equals to IR, right? Now I equals to V over R, right? So now we're saying what? This increase in resistance results in an increase in voltage across this part of the circuit which is connected. Now we increased this, right? So now when we increase this, it will affect this, right? So now but this one will increase, right? That is basically what will happen. Now remember, this is true. Why? Because if we remove this, it means okay, we'll be left with the 6 ohm resistor. Now the RP is going to be is not going to be just that. We're going to have 6 plus that, right? Now if we want to calculate the current in this form, we're going to say what? 6 plus 9, which is going to be 15, right? You're going to divide this by 15. Then the current will decrease, right? It will be less than 2 ampere. But when it comes to the potential difference, if we want the potential difference of that one, right, we're going to use the 15, right, multiplied by what? It's this one, 6 multiplied by 2, which means the potential difference is going to be what? 12 volts, right? So now it's going to change the complexion of the story for this part here, right? Now, and again, remember, if it's going